What if you could type in any list of stocks and instantly see 100,000 different versions of what your future portfolio might look like? That's the question that guided our project. We wanted to explore how different combinations of the same stocks can lead to a very different risk and return outcomes, and how the best portfolio depends on what metric you use. So here's what we did for this project. We built a portfolio simulation engine that works with any set of ticker symbols the user chooses. And unlike the previous projects we did, they had a fixed set of stocks. This one let us use whatever stocks we wanted. So the code first pulls the monthly price data from Yahoo Finance and matches it with the words data for risk-free and market risk premium. Then we calculate monthly returns, excess returns, covariances, correlations, in each of the stock's betas. After that, we simulate 100,000 random portfolios by generating random weights for each portfolio. We compute the expected excess return and standard deviation, beta, Sharpe ratio, and trainer ratio. And then finally, the code exports everything into an Excel workbook with 12 sheets. Alright, so this slide shows an example of the Excel workbook that our Python code automatically generated. Here you can see several of the sheets we exported, like the correlation matrix, covariance matrix, equity risk premium, and monthly return. For this example, I used 5 tickers, which were Apple, American Express, Google, Caterpillar, and Coca-Cola. And all the number on the slides come directly from those stocks. Everything here, the returns and how each stock relates to others, was generated automatically by our code, and this Excel file organizes all the data we need before we run the 100,000 portfolio simulations.
Hi everyone, today I'm going to walk through the results of our portfolio simulation project using Tableau. We'll start by looking at how risk and return interact across thousands of randomly generated portfolios, and then highlight which portfolios deliver the highest Sharpe and trainer ratios. I'll finish by showing 2 additional visualizations that help explain why these portfolios perform the way that they do. So let's start with the first scatter plot, where each point represents one of our simulated portfolios. So here the horizontal axis shows that the portfolio's standard deviation, which is a measure of total volatility. The vertical axis shows excess returns, which is how much the portfolio earned above the risk-free rate. And the key idea for a client is that we want to move towards the upper left, higher return with lower risk. So you'll notice that most of the portfolios fall along a broad upward sloping cloud. That's the typical risk return trade-off. As risk increases, expected return tends to increase as well. Now the dark blue point is important because that is the highest Sharpe ratio portfolio, meaning it delivers the most return per unit of total risk. If you imagine investing your money, this is the portfolio that gets you the best bang for your buck when it comes to overall volatility. So this chart visually shows us where the most efficient portfolio lies relative to all the others. In this second chart, we shift from total volatility to systematic risk measured by beta. So beta tells us how sensitive a portfolio is to movements in the overall market. A beta of 20, for example, means that for every 1% change in the market, that portfolio's return changes on average by 20%. Our portfolios have unusually high betas because they're constructed from individual stocks with high volatility at a long sample window. So the vertical axis again shows excess returns. Once again, the colored point, this time in blue, like last time, marks the highest trainer ratio portfolio. So the trainer ratio answers a slightly different question, which is how much return am I getting for every unit of market risk I'm taking? Where the Sharpe ratio return rewards low volatility, the trainer ratio rewards portfolios that effectively use exposure to the market. This chart helps identify which portfolio does the best job at converting systematic risk into higher returns. So this third visualization compares the Sharpe ratio and the trainer ratio directly. Each circle is a portfolio, and the shading reflects the level of excess return. What's interesting here is that the relationship between the two ratios isn't one-to-one. A portfolio can score extremely well on Sharpe, meaning that it's efficient relative to total risk, but not rank the highest on Trainer if its beta is low. Similarly, a portfolio might have a strong performance relative to market exposure, but look less impressive when total volatility is considered. For a client, the takeaway is simple. The best portfolio depends on which type of risk you care about. So Sharp focuses on overall stability and diversification, while Trainer isolates the portion of risk that comes from broad market movements. This chart makes that distinction really clear. So finally, this fourth chart plots beta on the horizontal axis and standard deviation on the vertical axis. At first glance, it looks like beta and volatility move together as beta rises. Portfolios do tend to become more volatile. That makes sense because both measures capture some aspect of risk, but the spread in the vertical direction shows something critical. Two portfolios can have similar betas but very different levels of volatility. That difference comes from diversification. Even if two portfolios respond similarly to overall market movements, they can differ dramatically in how much idiosyncratic stock-specific risk they contain. The size and color of each point reflects excess returns and Sharpe ratio, which helps show that the most attractive portfolios generally offer a balance between total volatility and systematic exposure. This visual helps explain why investors consider both types of risk when constructing portfolios. So together, these four visualizations give us a full picture of the relationship between risk and return across thousands of portfolios. We can clearly see where the most efficient portfolios lie, and we can explain to a client why different risk metrics like Sharpe and Trainer might point to different choices depending on their goals. Tableau helps us communicate these ideas visually in a way that's intuitive and easy to understand.
Okay, so for this project, we used ChatGPT to generate some Python code for us, and we used Chat to help us generate the Python code by giving it the details of the project, and we had to be very specific with prompting the AI to do what we wanted. And so for me, I had trouble with having the little box for the tickers to show up, so then I had to be very specific with what I wanted in that, and it also helped code in some generated scatter plots and calculations for us, and also if we got error messages, we would copy and paste the error codes to help troubleshoot, and ChatGPT would tell us exactly what to change and where to change, and it would be very helpful. And also we would use Python and Tableau together in this class for this project. So we used Python to calculate any data that we needed, and also create a few initial visualizations. And then so Python would create an Excel file with all of the data that we needed, and then we would put that Excel file into Tableau to help us create like interactive dashboards that would help us analyze the data better. And we would also use that to help analyze the data, as well as statistical theory and financial theory to help us understand what is happening with the data.
Hello, today I'm presenting the end-to-end financial analytics pipeline I built, which integrates every major tool we use in this course, from Words to Python, Excel, Tableau, and financial modeling. My project wasn't about using one tool at a time, it was about connecting all tools into a single workflow. Words provided factorial data, Yahoo Finance provided stock price, Python handled all the heavy analytics, Excel formulated everything into a professional 12-sheet workbook, and Tableau produced a final visual insight. ChatGPT supported development and debugging throughout the process. Python was the engine behind the entire pipeline. It aligned words and price data, calculated monthly and excess returns, estimated beta through regression, and simulated 100,000 portfolios. Then it automatically produced a 12-sheet Excel file with portfolio weights, betas, expected excess returns, covariance, correlations, and final risk-return metrics. Last but not least, we looked at visualizing portfolio insights. Using the portfolio metrics sheet from Python, I built two Tableau scatter plots, excess return versus standard deviation and excess return versus beta. I highlighted the portfolios with the highest Sharpe ratio and higher Trenner ratio, so we can clearly see which portfolio performed best on a risk-adjusted basis. This completes the pipeline end to end the data with modeling, reporting, and visualization. I did use artificial intelligence, as you may know, and that was a main point within this class, as well as all the other tools, Yahoo Finance, Words. I learned a lot from this class, and I really, really appreciate everything. Thank you.